All right, what up? Today's Tutor Plus is going to be covering adding mixed numbers, okay? Adding mixed numbers. So how do we do that? Well, there's a few ways you can approach it. I think this is the most helpful approach for doing this process. So I'm going to just show you real quick with two big examples. So you're going to have one example in red. That's going to be kind of the intro version, and then we're going to look at the black version that has one more element you have to take into consideration. Let's get into it. So if you start with the first one on the red, we have 3 2/5 plus 2 1/2. You're going to be adding them together. They're mixed numbers because they have a whole number part and a fraction part. All right. So that's why they call them mixed. So there's a couple ways to go about it. I think the easiest way to do it is to stack them first. So we're going to write it up and down as 3 2/5 at the top. And then I'll put 2 1/2 at the bottom. And we'll just line up fractions with fractions and whole number parts with whole number parts, keeping it addition, of course. Now think about this. To add fractions in particular, remember you have to add like denominators. If you look at 2/5, they have a denominator of 5 and a denominator of 2. You cannot add them the way that they currently are. We need them to be the same thing. So sometimes you have to multiply one of them or both of them by something to get the denominators to be the same. So I'm going to do that right now to kind of show you an example of what I mean. For example, I can multiply 2 times 5, and that would be a total of 10. I'm going to come out and give myself some space. That'd be a denominator of 10. But remember, when you're doing this, whatever you multiply to the bottom to the denominator, you have to do to the numerator as well. So I want to multiply the top one by 5 as well, and that's going to change 1/2 to 5 over 10. Still equal to 1/2, but the denominator is now 10. Now, we want the denominators to be the same, right? So the question is, what can I multiply the 5 by to get it to equal 10 as well? And if you're thinking 2, you would be right. 5 times 2 equals 10. So notice if I come out here to the side, kind of line them up, see how the denominators are both 10 now? They're the same. Just remember, if I have to multiply the denominator by an amount like 2, I got to multiply the same amount by its numerator. 2 times 2 at the top becomes 4. And so we have to adjust our fraction part to where the denominators are the same. We've got to think through our multiplication facts to figure out what we can multiply them both by to get them to be the same. But now that they are the same, check this out. I'm going to copy the whole number part back where it is. So 3 was the whole number part. 2 was the other whole number part. If you're looking at both numbers, add them up. But now I'm in a position where I can actually combine and add my fractions together. As long as the denominators are the same, it will stay the same. They're both 10, so the 10's not going to change. But I will add the numerators, 4 plus 5. How much is 4 plus 5? Well, that comes out to 9. And so we're going to go ahead and put 9 for the numerator and 3 plus 2, the whole number part we're going to do next. 3 plus 2 is 5 any day of the week. So it turns out that 3 2/5 plus 2 1/2 equals 5 9/10. 5 9/10. I'll say this. You want to get in the habit, if your fraction can be reduced, always check and see if you can reduce that fraction. But turns out here, it doesn't really reduce. So we are done. 5 9/10 is how you do that. Okay. So just one quick method for adding mixed fractions. So pause the video, slow down the video, rewind the video if you need to see that a second time. That's the beauty of the recorded versions of tutoring. But let's go ahead and take a look at the black example next, because the black example has a situation that we have to add on here. You're going to see what I mean in a minute, where you have an improper fraction that you're going to have to account for. Okay. So what I'm going to do is I'm just going to erase all my work. You can go back and rewind the video if you need to see that a second time or whatever. But now we're going to move on to the black example that you see. All right. So I'm going to change the ink to black so it all lines up. Okay. Just like before, we want to write them, rewrite them stacked on top of each other. So we're going to do 9 7/8 at the top. And remember, it's adding 8 3/4 at the bottom. So we're going to do that real quick. Line them up, line them up, line them up. Now, once again, if you look here, you're going to see that the denominators on the fractions component, they are not the same. All right, they're not alike. You cannot add fractions unless they have like denominators, right? Well, check this out. This time, it's actually not too bad, because if you think about it, the smaller denominator, 4, you could easily multiply 4 by a certain number and get it to equal 8 like you have at the top. So sometimes you don't have to multiply both. You really just have to look at on a case by case basis. Well, if you think about it, I could easily multiply 4 times 2 to get it to equal 8, just like the above fraction, right? I'm going to come out just like before, give myself a little bit of room for that whole number part, and then just go ahead and say 4 times 2 is 8, because it is. Just remember, if I multiply the bottom by 2, I have to multiply the numerator by 2 as well. 3 times 2 is 6, so that will change from 3 over 4 to 6 over 8, but the whole number 8, I'm going to just bring that along now. That will stay the same, okay? Now, the beauty on this example is I don't really have to change the top mixed number whatsoever because it already had a denominator of 8. But let's go ahead and just copy it over so everything's lined up. So if you look on the right side here, this is really where you want to be focused right here. We've already adjusted the bottom mixed number. And so now you look at the mixed numbers, but the denominators are the same. They both have a bottom number of 8, denominator of 8, right? Well, just like always, once the denominators are the same, the beauty of it is you keep the denominator the same. It's going to stay 8, and you just simply add up the numerators. 7 plus 6 in this case. Well, 7 plus 6 is 13. So we're going to put the numerator of 13, and we're going to add up the whole number part next. 9 plus 8 is 17. So this is going to come out initially to 17 and 13 eighths. 17 and 13 eighths. Now, here's what I'm telling you. Notice on this example, your fraction part looks a little funny because the fraction has it's really improper. The numerator is bigger than the bottom number. That's called an improper fraction. They usually don't want you to leave it as an improper fraction. So what do? Well, this is when we need to do a little extra step. 13 over 8 is an improper fraction. We're going to have to convert it to a mixed number as well by dividing that out, long division style. So remember, 13 over 8 is the same thing as saying 13 divided by 8. So the next step we have to do whenever we have an improper fraction for the fraction part of a mixed number, you got to divide the top number by the bottom number. 13 divided by 8 is what we're going to do. Well, 8 goes into 13 exactly one time. 1 times 8 is 8. So you just do your long division skill, subtract. That's going to be 13 minus 8 for a total of 5. So there's your remainder. So remember, when you get remainders doing long division, you can write the remainder as the numerator of a fraction. So since the remainder was 5, we're going to say 5, and whatever you're dividing by, the 8 will stay the same, right? So this apparently turns into 1 and 5/8, all right? 1 and 5/8. So think about it this way. You had 17 and 13 over 8. You just took the 13 over 8, moved it over to the side, realized that's the same as 1 and 5/8. So what you're really going to do is you're going to take the 17 that you already had. You're going to add the 1 and 5/8 to it. I'm just going to kind of stack it over here so you can see this. We're going to add those together. So if you think about it, the whole number part is just 17 plus 1. That's pretty easy math. That's a total of 18 whole parts, but you still have 5 out of 8, 5/8 left over. So that would be the mixed number. Your final simplified version would be 18 and 5/8. 18 and 5/8. This is what we do when you have a mixed number answer. You did everything right, right? If you look over on the bottom right here, I put a little arrow there so it points out. But notice the top number was bigger than the bottom number. That's called an improper fraction. So we have to take that 13 over 8, do long division, do 13 divided by 8, turns into 1 and 5/8 in this case, and you add that 1 that you get, that whole number part, to the 17, make it 18. 5/8 would be your fraction part. So anyway, those are the main things you're really going to be doing here. Whether it's adding mixed numbers or whether it is a subtracting, it's the same rules. You have to get common denominators, And so I would advise you to just stack them on top of each other and really pay attention to the denominators. Are they all alike? Or are they not alike? If they're not alike, you got to multiply it by some sort of multiplier until the denominators are the same. Just make sure if you multiply the bottom number by something, you got to do it to its numerator at the same time. Okay. And that's really how it is, So rewind this, watch as many times as you need to. I'll put a little attachment. You should see it in the email. It has some practice problems you can do along with the video. But I really want to just nail down those two dynamics that you are likely to see and let you have some clarity there. All right. We'll stop right there. That's adding mixed numbers. Hope that was helpful. Peace.